Today we're going to finish up section 3.4. It's kind of a long section since we are on day 3 of this, right? And the part that we have at the end is about estimation and mental math, both actually. And mental math is where we begin. And so we're going to take a look first at what is called front-end multiplying. So these are strategies for either doing it in your head, that's mental math, and getting the exact answer, or adjusting maybe the values that you were given so that estimation is used instead, making it therefore easier to do when an estimate is appropriate. So what does front-end multiplying look like? Well, front-end multiplying looks like taking the single digits that you're given and breaking them apart. So instead of doing 46 times 5, we would do 40 times 5, and we'd do 6 times 5, and then we'd add the results together. So what is 40 times 5? 200. What is 6 times 5? 30. And if we add these together, we get 230. It's basically a 3-step process. You've done 2 steps of multiplication and 1 step of addition. If it gets much more than about a 3-step process, it starts to look like something that doesn't really feel a lot like mental math. There's problems that I have seen used before, either in your book or on tests I've given or whatever, and the number looks instead something like 423 times 5. Okay, that's a 4-step process because you got to do 3 multiplications and an addition. Or what if instead it had said 2,423 times 5? There's a limit to what your brain can do in numbers of steps and it be reasonable, and maybe you can do that. But I would probably contend that your 4th grader is going to struggle with that in their head, which is kind of the point of what we're doing in these lessons, right? Is something that you could actually teach to a child at about the 4th grade age level at this point with this content and it work. So once we get too big, this particular strategy doesn't work very well, right? Remember, we've talked about that before, about the fact that some strategies really work well in certain situations and not so well in others. Compatible numbers is a really nice one. We've used compatible numbers for addition already. The idea of compatible numbers with addition is that there's certain things that add together and give you, zeros. We like 0 at the end of things. It makes it very friendly. Well, compatible numbers with multiplication is the same thing. There are numbers that multiply together and give you zeros at the end of their numbers and make it very nice. Do you see a couple of numbers here that you might multiply together because they work out just so nice? Okay, 5 times 5 is actually not, because it gives you something that's got 2 legit numbers. What else?
5 times 2.
The 5 times 2 is a really nice one. That gives me 10.
5 times 4.
And the 5 times 4 work out really nicely. That gives me a 20. Okay? So those are nice values to group together, and the real reason is because when I get the 20 and I get the 10 and I use them to multiply anything else, I'm really still doing pretty much, single-digit multiplication, because the 0 doesn't affect values, right? I get just zeros because of that. So what I end up getting instead is 20 times 8 times 10. 20 times 8 is 160. Times 10 would be 1,600. Yeah. So tacking zeros on things is very nice. The reality is all I need to do is multiply 2 times 8 here, and then I get 2 zeros. Okay? So compatible numbers. The next one's my favorite algorithm, algorithm for using mental math. So this is called thinking money. Okay, thinking money. And again, it doesn't work for everything because we don't have coins that are worth every value in our number system. We have some that are just really nice, right? The nickel is a nice one. Quarters, dimes, we have coins that are worth certain values. So a nickel would correspond to multiplication by 5, which is the problem that we have here. So this 5 here is equivalent to saying that I have 46 nickels. Everybody good so far? And multiply by 5 is like having a nickel's worth of value. And the question you're asking yourself is, well, how much money is this really going to be, right? Well, how does that help you? Well, the reason it helps you is because while nickels are not so very easy to actually work with because it's multiplication by 5, dimes are really nice. So if I had 46 nickels, how many dimes is that equivalent to? It's 23 dimes. How do we go from 46 to 23? You divide by 2 because it's 2 nickels and a dime, right? Okay, but multiplying by 10 is easy. Yeah? I mean, like, it's one of the best ones we can do because it's got a 1 and ones and zeros are wonderful. They just are. So I have 23 times 10 is what this ends up giving me. And what is 23 times 10? 230. Super nice, right? Turning nickels into dimes. If I can turn nickels into dimes, what do you think I might do with the number 25? It is a quarter, you bet. So this is equivalent to having 44 quarters. But again, kind of like nickels, quarters aren't especially friendly. I don't really want to multiply by 25. So what could I do instead? Say that really loud, Valerie.
You can turn it into a dollar.
You can turn it into a dollar. If I have 44 quarters, I think I might have had 44 quarters turning in some fundraiser money for my daughter the other day at the bank. They just look at you like you're crazy, by the way. 44 quarters. Do you know that that's exactly what they do is they pull 4 out at a time and they count numbers of dollars. That's what they do when they're counting it, to keep track of it all, to make sure they're really looking at quarters and not nickels and things like that. 44 quarters. So how many dollars is that? It's $11. But in the sense of what we're doing, a dollar is the number 100. Right? It's 100 cents, just like 25 is 100 cents for 25, the quarter is 25 cents. And what is 11 times 100? 1100. Yep. So we turn our nickels into dimes, we turn quarters into dollars, and we can think about this in terms of money. It's very specific, right? 5s and 25s, and that's kind of it for this particular method. But when it works really nicely. All right, and then I want to show you an estimation technique that you may or may not be aware of for multiplication, and it's a very friendly one. It is called Frontend Estimation. And what Frontend Estimation does is it turns it very much into this one over here that was Frontend Multiplying. And so, do you remember when I looked at this one with you and I was like, okay, really? The most you're really going to do is like 2 multiplications and then the addition in your head, 3 steps. That's reasonable. The same thing's true over here. If I did this problem out, like actually front-end multiplying, I'd have 3 multiplications and then the addition. So what estimation does is it ignores the ones digit. And it says, you know what, yeah, there's something more at the end, but it's not really that much. It's not enough to worry about. So we would say something like this. We would take the 300 and we would take the 80, the first 2 digits, and multiply each of those by 4. So what's 300 times 4? 1200. And what is 80 times 4? 320. Okay, so the same thing we did for front-end multiplying before, and we rather ignore the 6. It's just not there. It's an estimation strategy. So we're ignoring any place value after the first 2. So if this were a 4-digit number, we'd ignore the last 2 digits. We'd only use the first 2. And then if I add these together, what do I get? Yeah, 1,520 or 1,520. So my approximation is 1,520. Any questions on that? All right, we will do group work for this one in a little bit.